Okay, so I'm going to do a tutorial on how I process now. I've changed my workflow since the last time I did a video on this. So I'll just go through it. Probably going to break it up into multiple parts because I think it's going to be too long for a single video. So I'll probably break it in half or in thirds, depending how long the first part of the video goes. But let me just get right into it. So the first thing I'm going to do is basically, so after I stack in Siril, I'm assuming you know how to stack and have a stacked linear photo. My first tool that I use is GraExpert. I don't know how you're actually supposed to pronounce that. I say GraExpert, but whatever. This, and I'm using release 3.1.0 release candidate 2, which I believe is the newest version. Now, I'm also going to use Siril and Seti Astro tools, and they're not the newest version, but I'm pretty sure if you have the newest version, it'll be, fairly similar. So I'm going to load my picture. I'm going to load the rosette, 12 minutes of rosette data. I got to find it first. I believe this is it right here. I already went through, I already processed this, so I'm going to have to rename my files slightly differently, as you'll see. But yeah, this is just 12 minutes of data from Bortle 8.9. It's basically Bortle 8.5, if you want to be technical. And yeah, it doesn't look like much now. So the first thing I'm going to do is I usually, especially if the data is dim, is I usually up the stretch preview to 30% so I can see things a little bit better. And for like nebula that take most of the frame up, I don't use AI background extraction. I typically use, actually there's some stacking effects here I want to get rid of first. So if there's any stacking effects like here on the right hand side and on some other edges, there's some weird effects. I crop that out first. So I'm just gonna crop this in a little bit. By the way, you use the middle mouse wheel to zoom in and zoom out, and then you use the left mouse button. You click it, and then you can drag the image around too. So yeah, I'm just gonna crop off the edge, try to center it as best as I can. This is just a tutorial, so I'm not going for perfection here. I'm just showing you what I do. Yeah, so that's another thing I should mention. I'm just showing you what I do, and when I actually do process an image carefully, I spend more time on these steps, but I'm just giving you a gist of what I'm doing here, so it's a little bit quick. Okay, so then, as I was saying, if I have a nebula which takes up most of the frame, I don't use AI background extraction. I use usually this thing, Krigging, I guess it's called. If you look at the drop down, it's Krigging. I use AI on, say, a galaxy. If I have a galaxy that's just a portion of the frame, I'll use AI and see what it does. But typically, I don't use AI that much. I usually use Krigging. So it's a little bit hard to see, but there's not much gradient here. It's a little bit brighter in this corner, so I'm going to put a couple points here. I usually like to balance off like all corners just to put one. So I'm not going to put that many points down. By the way, for those of you that are new and never done this before, you're basically putting points down, and basically how you do that, I forgot to mention how you do that for people that are completely new. I'm assuming that most people kind of know what I'm doing here, but just in case you don't, you left click and that puts a point down. Right click removes the point. And when you put the points down, you're putting points down where there basically isn't nebula to sort of balance out the light profile of the image, which is background extraction. So there's a lot of nebula here. It's a little bit hard to see, but at the top, there's, a little bit of red here. So I don't want to put it where there's any red. So I'm trying to put it where there isn't any red. There might be some red over here, but the point is that this is lighter. This corner here is lighter than the other corners, so that's why I put a few down there. And then I run it. If I don't like it, then I, change the points and rerun it until I like it. So the question is, how do I know when I like it? I'll show you after I run it. So let me run the background extraction. And if it evens out the image, I like it without, and if it doesn't remove much nebula, I like it. So first off, does it even out the image? Yes, it evens out the image. So that's good. Does it remove any nebula? So what I'm going to look for is go to the background and see if there's any sort of red removed or any excess colors removed. It removes some colors over here, but overall I'm pretty happy with how that worked. Again, most of this is actually nebula if you get enough, if you can increase the signal noise ratio a lot. So that's why I didn't put many points down for this particular case. Anyhow, that's what I do for background extraction. It's pretty simple. I reset the grid, reset the sample points, I should say. And then I go on to deconvolution. Okay, so for my camera, I know what the WFHM is. It's about 10 to 11. Now, how you can figure it out on your picture here is you take sort of an average size star, not a big star, not one of these stars, an average size star like this star here. And you count basically how many pixels, you can see the pixels, right? How many pixels are across the middle. This gives you approximate estimation. So say from like here to here. It's technically like 90%. So it's technically say from here to here. So for me, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why I usually set my FWHM between 10 and 11 because it's between 10 and 11. I mean, if I look at some stars, it's 10. If I look at some stars, it's 11. It's somewhere between 10 and 11. I just put it someone randomly between 10 and 11, like 10.6. And then I run the deconvolution and see how it looks. If it's too strong, I reduce it. If it's not enough, I increase it. But usually I start with 0.8 for the object deconvolution. So in case you're new to this, object deconvolution is basically trying to, based on the stars, because the stars should be points. So it's trying to increase the contrast, which essentially sharpens the image. But this is just focusing on the object, so mostly the nebula is trying to sharpen. If you've never run it before, you have to select a object convolution model first. I'm using 1.0.1. And I'm using 1.0.1 for the background extraction. And eventually, I'm going to be using 1.0.0 for the stars. But I'm not doing the stars now. I'm doing the object deconvolution. So this is the first one I'm using. So if you never use this program, the first time you run it, it's going to ask to download the model. It'll take a few minutes depending on how fast your network is, and then it'll install it, and then it'll run it. But since I already ran it, it's already installed, and it'll just run. Now, I will say that this is a beta version of GraExpert, and it does sometimes get stuck, and you'll have to start all over again if it does. So let's just see what happens. Hopefully it doesn't get stuck, and I'll run it, right? So actually I'm gonna make my computer go a little bit faster here. My computer's pretty fast. I can give you the specs later, but depending how fast your computer is and how big the file is will dictate how long this takes. And I think it just froze. I'm pretty sure it just froze. Yeah. So GraExpert does this randomly. It doesn't always freeze. Sometimes I can edit like a few pictures in a row without it freezing at all in any step. And then sometimes it freezes. So it's kind of a pain. You could save what you did on each step, but it typically doesn't freeze for me at deconvolution, which is why I didn't save it yet. So let me just do what I did before. Sorry about the freezing, but it's just what happens. All right, so let me open up again. I know what I did for the background extraction. I got to crop it a bit first, so let me do that. All right, let me crop. Let me do the crittering thing. I did like 3.0, 1 point here, 1 point here, 1 point here. Run that. Okay. Reset sample points, and then I'm going to go deconvolution. Bump this to like 10.6-ish, and then run it. Hopefully it doesn't freeze up this time. All right, it didn't freeze up that time. Now let's see what it did here. So if you focus on these features here, this is before deconvolution, and this is after. So it sharpened this up a bit. Sometimes it does it too much, and you want to turn it down. Sometimes it does it too little, you want to turn it up. But I find 0.8 or 0.7 usually works pretty well for deconvolution. So now what I'm going to do is save the image before I go on. I'm not done with this yet, but I'm going to save it first. So I'm going to type in rows. What is it? Well, it's all right. It's got to be fine. This is I forgot. This is the default naming of how it's going to save it. So it's going to, this is the file. This is GraExpert, and it did deconvolution. So I'm going to save this as 2 because I already did this once. Hit save. So now at least the background extraction and the deconvolution is saved. If it locks up again. And then what I want to do is load that image. You can get rid of all these intermediate files and just focus on the final corrected version after, I do the star deconvolution, the denoising. But I save it frequently in case it, locks up. I don't want to redo everything from scratch again. So now this is the object deconvolved image and background extracted. So now what I want to do is go to deconvolution again and do the stars. Now for me, whenever I load the program, the star deconvolution model doesn't load, so I have to load it. Again, if you never ran it before, it's going to ask to download the star deconvolution model, and then it'll run it after it's done. But since I already downloaded it, I don't have to do that. Now, sorry about the coughing. I have a little bit of an allergy, so I'm going to be coughing every once in a while, which is a little bit annoying. But now what the star convolution is going to do is it's going to try to tighten up a lot of these stars, particularly the smaller stars. Just from experience, I realized that a lower number usually works better. I usually start with 0.2 and then either go down or up for 0.2, depending on how well 0.2 works. So then we just run it. You keep the FWHM the same as the object deconvolution, so I don't change that. I'm just running this again. Hopefully it doesn't crash or freeze up. And we'll see what this does. I think it's going to freeze up again. Yeah. This program is nice, but it's kind of annoying, as you can see. It normally does not actually crash that often. Like I said, I can sometimes edit multiple pictures, go through all these steps without it crashing once. And then sometimes, like when I'm trying to make this video, it'll crash multiple times, which isn't ideal, but it is what it is. All right, so let's go to this here. I will again go to the star deconvolution, load the model. And bring this down. Bring this up to 10.6. 10.7 is fine. Bring this down to 0.2. Yeah, so sorry about the coughing, but it is what it is. All right, it worked that time. So let's see what it, let me zoom in and see if it worked well. I think it worked too well. So yeah, so if you zoom in on the star here, see it tightened up, but see it created like a ring around the star. So it's actually not that bad of a ring, but I try to like not have any of those rings in there. This actually isn't too bad. This is borderline acceptable. But what I'm going to do is drop it down to 0.1 and see what happens. Hopefully it doesn't crash. All right, that's probably better. Let's see. Yeah, so it cleaned up the stars and there's not much of a halo. Like if you go all the way, say, to 0.6, you'll see a very good example of what it's not supposed to look like. Yeah, so sometimes you have this dialogue here that you can't really get rid of. But yeah, see all these stars have these dark rings around them. See this star right here, like before I did it, looked like this. After it has this dark ring around it. That's definitely not what you want. So that looks horrible. So for this particular picture, 0.1 looks good. And it's kind of random. A lot of the times 0.2 looks good, and then sometimes it doesn't look good, and 0.1 looks good. Sometimes I find you have to actually go down to 0. You figure 0 doesn't do anything, but it actually does do something. Sometimes I have to go to 0.3 or 0.4, but most of the time, 0.1 or 0.2 is the one that works for me. So anyhow, that tightened up the stars, as you can see. So that's good. Now I'm going to save this in case it screws up again. So it's got to put GraXpert stars decon. So now it's in the object deconvolution and the star deconvolution, which is fine. I'm going to load that up again, and I'm going to do denoising. So, so here's this picture. Oops. So denoising. Yeah, you have to pick a denoising model, and then if you haven't run it before, it's going to download and then run. But since I already downloaded it, I don't need to do that. So I'm going to go to denoising. Almost all the time I go between 0.7 or actually 0.65 sometimes to 0.85. Obviously, the more noisy the picture, the higher this is. But for this one, I'm going to start at like 0.8 and see how it looks. So let's see if it freezes. Hopefully it doesn't freeze. So these are the specs of my computer here. I have a Ryzen 9 7945HX, 32 gigs of DDR5 memory, and I have several NVMe drives. The main one is the Samsung SSD 990 Pro, 4 terabyte. So I have a pretty fast machine, and I also have a it's a laptop, but 4090 with 16 gigabytes of VRAM. So it's a pretty powerful computer. Yeah, that actually looks pretty good. So again, you just have to play around with the slider and see what looks good. I just know from experience that somewhere around 0.8 is probably going to look good for this particular picture, and it does look pretty good. So that's it. So I'm going to save this, and it automatically puts the noise at the end, so that's fine. And that's basically where I start, right? So it still doesn't look like much, but for 12 minutes, actually this picture doesn't look that bad by itself. But I'm going to get it to look quite a bit better than this, as you'll see. So I'm going to close this. The next thing I use is Siril. So let me go to Siril here. Again, Siril has been updated since this version that I'm using. I'm using 1.4.0 beta 3. Pretty sure the updated version is pretty similar to this. Anyhow, I'm going to switch to the Astro directory. All right, so I do this fast. I forget some people have never done this before. So to switch, the first thing you need to do in Siril when you're working with it, if you want all the files that you're working with, sorry, to go in a certain directory, is you have to switch the home directory, which is this button here, to where your Astro pictures are. So this is the series of pictures I was just working with. They're in this Astro. Actually, it's an Astro partition, but whatever. Where all your pictures are, you gotta pick that folder. So that's the first step. And then I'm gonna open. So after you pick the home directory, right? Oops, Siril just crashed for some reason. This is great. Okay, let's try that again. All right, so you pick the home directory, which I'm in. Okay, so that's fine. And then I'm gonna open the picture, right, that I just saved. Now, when you open it, it's going to look completely different. Well, first of all, when you open it, it's going to be in the linear phase. So what I do is I change this to auto stretch, and also I do high definition. It just makes it look a little bit better. So you can see it looks quite a bit different than it looked in GraXpert. The stretch is different, and also it's a bit redder. But we can use that to our advantage. So the next thing I do is color calibrate, and I don't do the photometric color calibration. So there's a way you can color calibrate in Siril. So what you would do is you first plate solve. So you go to Tools, Astrometry, and then Image Plate Solver, and you just hit OK if you have a dedicated Astrocam. All the stuff is here that it needs to solve. And then you can do what's known as, if you go image processing, color calibration, photometric color calibration, which basically calibrates the colors based on a known catalog. So it automatically calibrates it for you. So let's just see what this does. Do not. Okay. So it made it quite red, and it kind of worked, but let's go back. It looked like that. There was some yellow in it, and here it's basically all like red. So this is maybe scientifically more accurate, but I find this looks better to me. I have more yellows in here, more oranges, and more reds on the outside. So I'd prefer this look than the color calibrated look. And I almost always prefer the manual sort of look as opposed to the color calibrated look. So I'm going to manually color calibrate. I'm not going to do the photometric or spectrophotometric. I'm going to do the first one, color calibration. And what I do it actually twice. I'll show you this in a second here. But the first thing I do for a HA dominated nebula, as the rosette is, I pick a part of the background which is actually greenish, right? So over here it's a little bit green. So basically I with the left mouse, I click and drag and just pick a little box here. A little box where it's a little bit green. I hit use current selection, and I hit background neutralization. All right. And you might say, isn't that kind of red like it was before? And no. I mean, I can go back 2 steps. Oh. Well, whatever. I can't go back 2 steps, but it's definitely more yellow here, right? So what that does is make the whole image look redder. But still the middle's sort of yellow, right? And I still have some oranges in here, which is what I want. Then what I do is I go down to remove green noise. I particularly like not average neutral, but maximum neutral. It's just my preference. You can go through these different options and figure out what you like, but I like maximum neutral myself. And I just keep everything default and I hit apply. And that removes a little bit more of the green. And I'm going to actually color calibrate it again, as you'll see. But before I do that, I'm going to remove the stars. So I'm going to do star processing. I'm going to do desaturate stars. Now, for some reason, after Siril 1.4 came out, when I desaturate the stars, sometimes it screws up the image and everything gets dimmer. If that's the case, I know that star removal is not going to work right, and I undo desaturate stars. So let's see what happens. Yeah, see the image got a little bit dimmer? See? So I think it's a bug in this version of Siril, because that didn't happen to me in the other versions of Siril. And I know from experience that if it gets dimmer, the star removal isn't going to work very well. So I undid it. But generally, I would want to do that to desaturate the stars so they're easy to work with later on. But if it's going to screw up the star removal, then I don't do it, and I just undid it. So I'm going to do StarNet removal. So what you do to get StarNet working is you download the StarNet CLI. You Google it, and then you put it in. Let's see where you put it. You put in miscellaneous. You hit this button here, this folder, and then you point it to the StarNet++ exe file. Once that's there, you can run StarNet and remove these stars. So you go star processing, StarNet removal, star removal, and you just let it run. Oh, by the way, okay, so let me explain for those of you who haven't used Siril. This is just a preview. The image is not stretched yet. I haven't stretched it at all. This is what it looks like. When I hit auto stretch down here, it's just a preview of what it looks like. So when I run StarNet here, I keep it as a linear image. So I keep this checked and I keep this checked. So basically this is how it is by default. I just keep everything as default and I hit execute. So this will take a little while. Again, my computer is pretty quick, and the file isn't that big. It's like 100 megabytes. So it goes pretty quick for my computer. But, this could take a while if you have a slower computer or you have a big file. But for me, it goes pretty quick. It's almost done. Okay, so that's the picture. And you can already see there's a lot more there than you think. Of course, there's a lot of noise here, but we can work on that later. Now what I do, though, is I'm not done. On the starless version, I color calibrate again. So this is a trick that I learned or figured out at some point. So I'm going to select a part of a background, like a part that's not a nebula, where it's a little bit green again, like maybe over here. I hit use current selection, do background neutralization, which didn't do anything. Okay, I'm going to do it again, but this time I'm also going to select a swath of the sort of hydrogen alpha area, like basically the middle of the thing, and basically, have not any background here. It's all nebula. And I hit use current selection for the bottom here. Then I hit apply. You see, this made it more blue. It's a little bit hard to see, but if you stretch the saturation, this is blue, and actually there's some greens in here too. So what I'm going to do now, in the background looks absolutely horrible. Like over here looks really bad. But that's not the point. What I'm going to do is I'm going to make the middle of it more blue and green and everything that isn't red and orange, and blend this image with my red and orange image. But I'm only going to blend the middle of the rosette. So the fact that the background looks horrible doesn't really matter in the end. As long as the middle looks okay, which it does. That's the important thing. I'm going to close this, and I'm going to save this. So how you save in Siril is you hit this thing here, not save, this down arrow. I'm going to save this as, I'm going to put BL at the end of it for blue. I'm going to save it, and that's it. So that's all I do with Siril. But the important thing is I do 2 different color calibrations on my own manual. So let me stop the video, because that's basically part 1.